and welcome to the videos on securitytube.net. This video is on web or wired equivalent privacy, which was a part of IEEE 802.11 security standard. This video will first discuss about web and its working, how exactly packets are encrypted with the help of web, and what kind of security the web can provide. In the latter part and in the next video, I'll be discussing more about the problems with the web, why web is completely broken and it cannot be fixed, and it is also known as worst ever privacy. Wired equivalent privacy is mentioned in IEEE 802.11 September 99 standard, and this was the only encryption algorithm mentioned in IEEE 802.11 99 standard. Web uses stream cipher RC4 for confidentiality, and it uses CRC32 function for integrity. So the actual encryption will be done with stream cipher RC4, and for maintaining the integrity of the message, CRC32 will be used. Web is currently completely broken and it is deprecated from wireless security measures, but still there are lots of devices in the field which support only web as encryption algorithm. So if you go around on hotspots or on airports or on coffee shops, you will find lots of APIs which are supporting web. Still it is completely, even if it is completely broken, lots of people still use web. How exactly web works? For any simple algorithm like web to work, there has to be some initial shared secret between transmitter and receiver. Transmitter will apply that shared secret to encrypt the packets, and receiver will apply that shared secret to decrypt the packets. Now similarly in web there is a key which is shared between access point and station. Now key will be a finite length key, say 64-bit or something. Now the incoming message is going to be a variable length message. So either we can use some block ciphers. In block ciphers the same key will be used again and again to encrypt all message, or we can use some stream ciphers in which with the help of the key a key stream will be generated, and then this key stream will be actually applied for encryption. Now web actually uses a RC4 stream cipher algorithm. So key will be given to RC4 block. RC4 block will generate a key stream. Okay. Now for a moment forget about this IV. Only consider that key is given to the RC4 as input, and RC4 will spit a key stream as output. Now this key stream will be XORed with the plain text message which is to be transmitted, and the XORed combination will be used as a cipher text for actual transmission. Okay. So station, if wants to transmit some packet to access point, it will give key as input to RC4. It will generate key stream, then it will XOR this key stream with the plain text message, and it will generate cipher text, and the cipher text message will be actually transmitted to AP. Now what AP will do? AP is also having the same key. AP will also generate the same key stream. Now since the XOR function is associative, if we again XOR this cipher text with the same key stream, we can get the plain text message. So access point will be simply generating key stream, and it will be XORing the cipher text message with the key stream, and it will generate the plain text message. Okay. This is the simple working of web algorithm. Now let's see the importance of IV. Now if I have a plain text message, one plain text message, I will XOR this with the key stream and I will get cipher text message. Now for every plain text message, the key stream is going to be constant because we have a same key at transmitter and receiver. So the key stream generated is going to be constant. So it will be very easy for the attacker to guess the key stream, and it will be very easy to generate the plain text with the cipher text message. Okay. Now to avoid this ability, web introduces this IV or initialization vector to the key stream. The initialization vector is concatenated with the key stream just to make the key stream random for every packet. So IV is a 3-byte or 24-bit value which will be concatenated with the key stream, and this whole concatenated seed is passed as input to the RC4 algorithm. RC4 will generate different key stream every time if IV is not constant, and thus the attacker will not be easily able to generate the key stream and the web will not be very easily broken. That was the thought behind introducing initialization vector into the web packets. Now let's talk about some numbers. IV or initialization vector is 24-bit or 3 octets. The key size is either 40-bit or 104 bits. Initially it was fixed to 40 bits. After that it was found that the fit for 40-bit key size is very small and it was very easy to launch attacks on the web. So after that, to make web little bit stronger, the key size was increased to 104 bits. So the whole seed will be either 40 plus 24, that is 64 bits, or 104 plus 24, that is 128 bits. So the seed will be either 64 bits or 128 bits. Okay, seed is IV plus key. Okay, now how exactly the encryption is going to take place? Seed will be passed to RC4. RC4 will spit a key stream as output. Now for encryption, the ciphertext will be derived like key stream XOR with plain text, and ICV is also added at the end of the packet. ICV is simple CRC32 function. Now CRC32 ICV is added to keep the integrity of the message, and the in between intruders should not be able to tamper the message. To avoid this tampering of the message, the ICV is introduced. At the end of decryption, the plain text will be derived by XORing the ciphertext with the key stream. Okay, so web is based on this simple RC4 stream cipher algorithm, and ICV is also added to enhance the integrity. That's all about this video. In next video we'll be talking more about the weaknesses in web, what kind of attacks are possible on the web, and about the tools which can help us to launch these attacks. Thank you for this video.